good morning, good evening, wherever you are. It's a pleasure to have you on this Couchbase webinar. We are February the 14th, it's Valentine's Day, and today I am very happy to welcome Jeff Lockhart. Jeff is a seasoned software architect, entrepreneur, open source advocate, and Kotlin Multiplatform enthusiast. His work on offline first mobile app solutions led him to author Kotbase, I think it's codebase.dev, an open source Kotlin multi-platform library for Couchbase Lite. Jeff, thanks for joining us. I have I have a couple starting questions for you, and then I will disappear and I will take any questions that people have on the chat. So don't hesitate to ask questions on the chat, on the Q&A panel. We'll try to answer those questions as we go. This webinar is being recorded. And so, Jeff, without further ado, who are you? What led you to Couchbase, and what led you especially to build a Couchbase Lite integration with Kotlin?
Yeah, so I've worked with native mobile apps for a while, over a decade now. So I've built one successful company, working on another right now, but I like this early stage startup part of a business, and in that last company, we did a lot of explorations on offline first mobile applications that can provide users with a good experience no matter what their connectivity is. And so we worked solving that problem ourselves for many years, and eventually I ran into Couchbase and did a lot of proof of concept. And this was right around the time that Kotlin Multiplatform was also coming out in its early stages, alpha. And so I kind of saw early on that there was a lot of opportunity for both of these technologies. And that's what eventually gave me the idea to build this open source library that allows using Couchbase within Kotlin Multiplatform. And I've found a lot of success. I've used it in a few projects, and open source, so it's available for anyone now to build on. So I'm excited to share it today.
Thanks for that. So just one additional question that's more of a personal curiosity. When you built it yourself, like, what was the worst problem you had to manage? Was it like offline connectivity and sync, or was it a local actual database, not just a local cache? I mean, there's a variety of.
Yeah, we really focused on it being a local database from the start, not just a cache. But I know a lot of solutions just kind of go the caching route. But there's just so many things you need to manage between the synchronization. You got multiple clients talking to the same backend, possibly modifying the same data. And it is a heavily workload. So we had a lot of scaling problems as our user base grew, and just, yeah, it was really great to start using Couchbase and just experience out of the box, a few lines of code, having it do a lot of things that for years were a difficult challenge. So.
Oh, good stuff. Awesome. So why don't you share your screen, and then the floor is yours. Tell us everything about Kotbase.
Thank you. So I put together just a few slides to kind of introduce. Again, I'm gonna talk about my library, which I decided to call Kotbase because of that combination of Kotlin Multiplatform with Couchbase Lite. So just as a kind of introduction to Kotlin and Kotlin Multiplatform, I think most have heard of the Kotlin language, are familiar with it as a JVM language. Compiles to Java bytecode, runs on the Java virtual machine. That might be an Android app, desktop environment, server environment. But Kotlin is actually a multi-platform language, and Kotlin native, this flavor of Kotlin, can compile the same common Kotlin code to LLVM bytecode, which can then be compiled down to native binaries for platforms like iOS, macOS, Linux, native Windows. Also, there's a flavor of Kotlin for JavaScript. And the newest platform supported by Kotlin is actually WebAssembly. This is an exciting new development with WebAssembly becoming really interesting for the ability to run really performant code on the web. But today we're mostly going to focus on just the Kotlin JVM, Kotlin native flavors with a sample app that runs on Android, JVM desktop, as well as iOS.
So that's a good time to ask you the first question, which is like we put aside WASM, and I was so focused about WASM that I forgot the other one, because I'm assuming it's very new, and someone is asking how mature is the Kotlin native side of things for iOS. Do you consider it production ready?
Yeah, so the Kotlin native flavor of Kotlin has been around for years, actually, and it compiles to C code or Objective-C code for iOS, and that gives a kind of an idea of how old the technology is, because now we've got Swift on iOS, and so there's active development to actually produce Swift native code. But yeah, Kotlin native itself is stable, and there's a lot of different elements of the Kotlin multi-platform feature set, and so there are things that are involved with Kotlin multi-platform that are not as stable, but Kotlin native itself is very stable. It recently went through a rewrite of the way it does memory management. So initially it had a lot of restrictions on threading and where you could create objects and share objects with immutable objects, and that's been entirely rewritten, and the new memory manager behaves just like you're used to with the JVM with garbage collection. But yeah, the Kotlin native portion of Kotlin multi-platform itself is stable. On the other hand, on this slide, I just wanted to kind of show how Kotlin multi-platform, one of the things that makes it really unique compared to other cross-platform technologies, is the ability to kind of use it in different sizes depending on your use case. And so if you have existing native apps, there's opportunity to really just introduce a small piece of shared code, and that works quite seamlessly because of the way the interop works between the native platforms. You could get to the point where maybe you're sharing all of your business logic, and maybe you just want to stick with native UIs because you want some of that native platform feel in your user interfaces. On the other hand, you also have opportunity to write your UI in Compose multi-platform, and Jetpack Compose is the UI toolkit from Google. It's heavily used on Android. JetBrains, the company behind Kotlin, has taken that and ported it to the native platforms and the JVM. So Compose multi-platform itself is actually one of those things that's in various stages of stability. The Android side obviously is stable. It's been around for years. The desktop port of that for the JVM is also considered stable, whereas the iOS native implementation is still in alpha right now. I think it's just about to be promoted to beta in the next few months, I believe. But that's exciting. And today we're actually going to look at how that works in the sample app that I created and how that works on iOS as well. So, and then a little intro for Couchbase. I know many of you are much more familiar with the technology, but I just wanted to, for those that aren't as familiar, Couchbase I like to think of as JSON plus NoSQL. But at the same time, it kind of takes the no out of NoSQL because you have SQL++ as a query language. So a lot of the familiar SQL syntax from relational databases you can use in Couchbase databases, as well as some features to handle querying deeply nested JSON as well. And then the components of Couchbase Mobile involve the Couchbase Lite database on the client side, a sync gateway web application that manages that synchronization with a Couchbase server backend. And so I've got local instances of this Couchbase server and sync gateways deployed so we can actually see how that works with this sample application in Kotbase. So going back to kind of the multi-platform architecture, you have opportunity again to kind of share any of the business logic in any of these layers of your application. Today, we're going to be looking at this sample application I built for Kotbase, which again uses all the way to the UI Kotlin Multiplatform. And the Kotbase library itself sits right down here in our data layer with the Couchbase Lite database. And like I mentioned before, this application will run on Android, iOS, and desktop natively. And then something I haven't finished yet, I was hoping maybe to be able to give a little demo as well today, but in the future, I will be adding an example of how the same application would work if you wanted to use Swift UI on the iOS side with the Compose UI just for Android and desktop. And I've got some code already in place for that, but it wasn't ready for the presentation today. So keep an eye out. All of this is open source. This is on the Kotbase repository on GitHub. I'll have links at the end of the presentation. So one of the things to be familiar with the way Kotlin Multiplatform works is you have this concept of source sets. And this is how you are able to share common code with different platform targets. And so at the top of our hierarchy here, we've got our common source set. Then we've got targets like Android, targets like the JVM desktop. And then down on the native side, we often have these intermediate targets that can actually allow us to share code between a lot of the native platforms. So maybe you have some POSIX APIs that will work on Linux and iOS's platform. They've also been ported to Windows through the Min GW platform. And so specifically in the app we're going to be looking at, this is kind of what the source set hierarchy looks like. So we've got our native or our Android target, our native iOS targets, and then the JVM desktop target.
So just a quick question. If you can go back to the previous state, yes, we left away the JavaScript targets. My assumption was that this is the browser-only JavaScript target, and this is why we are not going to talk about it with Couchbase Lite. Is that so?
Yeah. So the JavaScript target for Kotlin can run in the browser or Node.js. But yeah, this specific application, I didn't write any code to share with a browser target. There is a flavor of Compose multi-platform that runs in the browser. The most interesting is actually the WebAssembly flavor of that. It renders directly to a canvas. But there's also an HTML flavor of Compose if you want to use a lot of the same composable UI paradigms, but do it with our rendering HTML. There's a flavor that works for that as well. But yeah, with this specific application, I didn't share any code with JavaScript, but the nice thing about Kotlin Multiplatform is you have the ability again to share any pieces of your code with any of the targets that those APIs support. So you actually have a lot of opportunity where you could share, for example, maybe your data models or some of your business logic around handling that data, and write that in common Kotlin code, put it in its own module, and then share that with, a JavaScript flavor of Kotlin. So yeah, that's kind of it for the slides. We can go ahead and jump into some code. And I was kind of debating which which IDE I wanted to use when I was walking through the code today, because JetBrains actually has this new IDE out. It's called Fleet, and it's built from the ground up with Kotlin multi-platform in mind. And so in the future, it's going to be, multi-platform first, really the go-to IDE. At this stage, it's still in preview, so it has a few little kinks here and there, or features that aren't quite complete. But I do think I want to spend most of the time just in Fleet, because this will be, the most relevant going into the future with Kotlin multi-platform. But if I do jump around to Android Studio is also very well supported for Kotlin multi-platform. There's a Kotlin multi-platform mobile plugin for Android Studio, which adds some niceties around running the app on iOS. And some other nice things. So you can check out the Kotlin multi-platform mobile plugin on Android Studio. So switching back, we'll stay in Fleet as long as makes sense. But yeah, I put together a README that has a little bit of summary on stuff like configuring sync gateway. I don't want to go into too much detail on the backend side of things, but to get the app working, like I said, I did deploy a local instance of Couchbase server and sync gateway, and then described kind of how to get that set up. But from a project layout perspective, a Kotlin multi-platform project uses Gradle as the build tool. Here I'm using version catalogs for dependency management. So all the dependencies and the versions are defined here. And then the application mostly lives in this Kotbase notes subfolder with our source code here in the source folder. Again, Gradle is the build script. I can kind of show you here with Kotlin multi-platform. This is where you define your targets. So we've got our Android target configuration relative to that, our JVM desktop target. We just want to call it desktop to clarify that's the platform we're running on. And then we've got our iOS targets here. And those that are familiar with iOS native development are probably familiar with CocoaPods. Kotlin multi-platform has a CocoaPods plugin, which allows you to use native dependencies. And so this is actually what I found to be the easiest way with Kotbase as a Kotlin multi-platform library for Couchbase Lite to integrate that Couchbase Lite native dependency. And since we just need to do the linking to that dependency, then we use this link only argument. In the Kotbase library itself, it's doing the same thing, but it generates the Objective-C interop with that library so that the Kotlin code can actually talk directly with those APIs. And so anytime you have need for that in your Kotlin code, you can connect to native libraries as well. And we'll look into how that works with the different source sets. And then for dependency management, we can add different dependencies for each of those source sets we talked about. So for our common source set, we're adding that Compose UI and a lot of the related material design and icons, things like that for Compose UI. The app makes heavy use of Kotlin coroutines for reactive streams, and so we're adding that dependency. This is the Kotbase dependency. If you notice in the version catalog, actually, there's a few flavors of the Kotbase library, and I'm adding the one with the KTX suffix. And this adds, so just the Couchbase Lite, or the Couchbase Lite EE Enterprise Edition artifacts would be all of the APIs that are present in the Java SDK. And this KTX adds some additional Kotlin specific extensions that make some of those APIs a little nicer. And not to be confused with, there is a KTS extensions version of the Java SDK, but actually those APIs are all present in the core Couchbase Lite artifacts. But we'll take a look and see some of those APIs we're using in this app. So also using Kotlin X datetime and serialization. These are also multi-platform supported libraries for dates and serialization. And this is really nice for especially using Couchbase Lite as a JSON database to convert between raw JSON and our Kotlin objects. In addition, we're using Coin for dependency injection, and then Ktor client is a HTTP web client. And there's one use case for that in this app, but that's really helpful anytime you want to write multi-platform web APIs. That's a really useful dependency. So Android specific has some dependency itself, like for Compose, for using Compose within an Android activity, and then Coin for being able to inject like your Android context, things like that are specific to Android. And then similarly on the desktop side of things, this dependency here adds us a coroutine dispatcher that works for Swing, and that Swing is used to render the Compose multi-platform UI on desktop. And for the Android developers, this sort of configuration for the Android portion of the app is familiar. And similarly, there's just some configuration for Compose for desktop as well. And if I have time, I'll kind of talk through what Sky is as a dependency. And this will mostly come into play as helpful for doing Swift UI on the iOS side. But yeah, let's dig into some of this code. So again, the ideal is to keep the bulk of the code here in common. And this is where we've got our data, domain, presentation, and UI layers, dependency injection. And then for the small parts of the code that do need to be platform specific, we put those in the platform specific source sets. So we've got our Android, where we've got things like the Android manifest, our application and activity. So this is really familiar for Android developers, where you launch an activity. We jump right directly into our Compose app here, though. And so there's very little configuration that's platform specific. We'll look a little bit about how we're handling lifecycle here for replication. But similarly on desktop, we've got our main function, which launches again our Compose application, does a little bit of window configuration, but again, launches that same common Compose app. On the iOS side, it's a little bit different in that iOS requires an actual Xcode project. So we're not using Gradle to build our iOS app. We're using Gradle to build the shared portion of that code. And then the iOS app itself is written in Swift. And this is the other nice thing about Fleet as an IDE, because Fleet supports Kotlin and Swift natively. And so you can actually jump between the code, which is really nice. So for our iOS app, we've again got some replication lifecycle management happening here, but for the most part, we're just calling our content view. And then content view is calling our Compose view, which creates UI kit, UI view controller representable. So this is basically how you put UI kit within Swift UI. And then this is how we put compose within UI kit. And so this is actually our Kotlin code right here. And we can jump into this nicely from the ID and see that we're calling that same compose app under the hood. So why don't we go ahead and jump right to the compose app, and we can see this is the top level composable. This composable basically just does our routing for our screens. So we've got a splash screen, a login screen, and our main screen, and an edit screen for our notes. And at this point, why don't we go ahead and run the app so we can see what this thing looks like. So again, Fleet handles deploying to all of our targets out of the box, which is really nice. But we'll run here on desktop first. And I've already logged in, but ordinarily we'd get this login screen. And once we log in, we just have this display for our notes. We can make a note. And have a list of those notes. We can deploy this on Android and iOS as well. As you can see, we've already synced the note I created here on the desktop version of the app. And that's, again, using that Couchbase sync gateway. And there it is, popped up on iOS as well. Which is just, it's really nice how easy it is to hook that up and get native data synchronization. So as I create a new note, you can see that will instantly populate. Really in a period, just I'm debouncing the saving to the database there, but the sync technology uses WebSockets, so it's really fast and efficient. Couchbase has built a really awesome technology there. Well, cool. Let's dig into some of the data code that uses our Kotbase dependency under the hood. So we've got, first and foremost, our database provider, which is what creates our database, our local database. This code is pretty straightforward. We're just instantiating a database with a name. We're also providing a couple of contexts and scopes for coroutines, and this is really nice for managing the database's life cycle and where we're actually doing our database reads and writes. So essentially, we create a write scope, which we're not ever closing this database, but if we were to close this database, we'd be able to cancel this scope when we close the database and allow any asynchronous work that's relying on using that database to be canceled in the process. And then we're giving these coroutines a name so that if we're doing debugging, we can really easily see how we got onto that coroutine through our database scope or context. And then we're using the IO dispatcher, since that's where we want to do blocking IO work for Kotlin coroutines. In addition, we also have this user scope provider. So scopes and collections is a newer feature with Couchbase, kind of akin to schema and tables with relational databases. It allows you to kind of logically segregate your JSON data as makes sense for your application. In this application, I'm actually creating a scope for my user. And I don't know that this is probably typical. It's probably more likely you're creating scopes for entire companies or other use cases. But you know, this is my local database, so I'll create my own user scope. So this class basically provides that scope and gives us the ability to create collections within that scope. So this application really just has one collection. It's a collection for our notes. And then we're also using the default collection for storing the user itself, so we know who's logged in. So if we look at our user repository, this is actually where we're saving that user when they log in. So when they authenticate on that login screen, we'll call into this save user. Again, we're getting on that database write scope, and then we are creating a user document, converting that to a Couchbase Lite mutable document. So this is where we use that JSON serialization library to take our user document, which is just simply a user ID and a password. Ordinarily, you wouldn't be wanting to, you know, store passwords in a plain text database in production. But again, this is just a sample app, so a little disclaimer there. And then once we have that document, we can save it to our collection. So again, that collection is the default collection for our database. And yeah, it's just a simple document with the ID user, saves the user ID and password for the logged in user, so we can connect to the sync gateway when they open the app. Similarly, manage that user. If they log out, we want to be able to delete that user. So again, on the write scope in coroutines, we get the document from the collection, and then with that document, we delete it. And then this is where our reactive streams come in. So our UI is going to want to subscribe and do a lot of events based off of when a user logs in or when they log out. And so we create a state flow, which is a special kind of flow that conflates its current state. So we can always check, for example, if we want the current user ID, we can get the value from this state flow, get the user ID, and then you know, assuming it's not blank, they're logged in, and we'll have a user ID. So this state flow uses this extension. This is an example of an extension that comes from the KTX artifact of the Kotbase library. And this kind of builds on an extension that's in the native Java KTX SDK to essentially get the current version of the document and then subscribe to changes to that document. So anytime this save user or delete user is called, we're going to get our reactive stream is going to update. And that new user or null is going to flow through our flow. And we're going to then decode it into our user document, which we've already seen, again, using that JSON Kotlin X serialization library. And then this state in is basically what takes that flow and makes it a state flow. So we can always access the current value in this way. So let's take a look at our note repository next. The note repository is where we start doing some querying on our data. And this is what allows us to populate the notes list. It also is what allows us to search the note list. So if I type in that search, it's going to start to filter. And I've got this little toggle up here to switch between two types of queries to do that filtering. There's two ways you can do this type of querying. One is using a like query on our search terms, and the other is using the full text search functionality of Couchbase. And there's subtle differences with the way those queries work. The full text search will actually do stemming of your search terms. So you can do things like, I don't know if I have enough notes in here at this point, but let's put some. So if we were to, type CA into the Lite query, we're getting results that include CA, both of these. Whereas if we do this same querying with a full text search, CA actually doesn't stem to a word that is found yet until we actually type the word cat, and then we're going to find both of these. So little subtle differences, but as we'll see with the Lite query, they're just a little bit different in their implementations and how we can create indexes. But this first piece of code here is actually what creates our full text search index. And so we, again, are going to want to do this every time a user logs in. So we're subscribing to our user state flow. We only care about those users that are logged in. So we filter out the null ones, and then we create that full text search index on the title and text properties of our documents so that we can search both. This is just a shortcut to get our collection within our user scope, the notes collection. And this is where we're actually doing the querying. So we have our base query where we're doing our select. This syntax here is actually another thing coming from the KTX extensions. It's a little bit more concise than the version that you'll see in the Java SDK. So we're selecting the ID of the document as well as the title, text, and then the modified date. Let's take a look at our note document so you can kind of see how that looks. Again, title, text, and then an info subdocument, which has our author, created date, modified date. So in JSON, we're embedding this subdocument. And in our query, this is kind of where we're using a syntax that's unique to SQL++ and JSON querying, where we can address that subdocument's modified property. Again, we're doing that from the same database collection. And there's a couple APIs for creating queries in Couchbase Lite. You can either do this builder syntax, or you can actually do a raw query syntax. So I put in what this same query would look like if we were using the raw query syntax. Simplified a bit, but essentially we're in this case, we're just going to get our first search term, and we can put the query in like this. So select, same thing, from our scope.collection. These backticks are what we use to escape things like special characters in our scope name. And then our where clause, this is where we would be composing it with the builder functionality from our base query, which is just the select from. And then we're going to take a look at what value our switch has in the UI and either do a full text search or a like query. So taking a look again about our like query, we're basically checking if title or if text are like our wildcard search term. We put the wildcard before and after so that we can find that text anywhere within those two fields of our documents. But then what we want to actually handle is multiple search terms. So that's where the query builder API is actually really nice here, because we can compose that query using functional APIs. And so we take our initial search terms and we use a regular expression to split those up into separate search terms divided by white space. And then we map that to this where expression for each search term. So again, we're converting the title and the text to lowercase, just like we converted our search terms to lowercase, and this allows us to do case insensitive search. So whether or not it's capital in their search input or capital in the database, we can handle that. And then once we create this part of our query for each of those terms, then we can use the functional reduce behavior to do an AND query across each of those. And so we'd be doing this and the same thing for each search term. So yeah, a little example there of querying. Similar thing with full text search. We're able to do it with our full text search index. So we get that index, we pass it into the match function. And this is going to be a lot more efficient. We actually didn't create an index at all for this query. And creating an index with these types of wildcard searches is really difficult anyway. And so full text search is really a nice feature for this type of use case. But wanted to kind of put an example of each of those in there. Also a way to just get our document for when we go to the edit screen so we can edit it. This is our document mapper where we map from our note doc, what we're storing in the database, to our domain doc. So this is what we're using in the UI. And then we're using coroutines again here for our save functionality so that we can debounce our save operations. This way, if they're typing text in the UI, every time that's called with a new character, we're sending a new save operation to our channel, but we're gonna only actually save after they've stopped typing for a half second. But again, using those reactive streams, once we've been debounced, we've got our note, we're gonna save it to the database. We get our current data in the database, decode it, update it with the data from the UI, and then encode it to our JSON document, our Couchbase Lite mutable document, and then save it to the collection. Similar functionality for deleting the note like we saw before. Let's go ahead and look a little bit more about how we would jump down into platform-specific APIs. And one use case I found while I was building this app is with our note domain model. If you recall in the UI, we're showing the last modified, and we're doing that as a time for these recently modified notes. But we might want to do that a little bit differently. If it's an older note, we might want to put the date. If it's a really old note, we might want to put the year. So this date formatting is actually a long-standing request from Kotlin Multiplatform to have in that Kotlin X datetime library, and it's in the process of being built. But for now, we're going to take that as an opportunity to look at how this would work in platform-specific code. So we can define this expect function in our common source set. And once we've defined this expect function, we can then implement it in our platforms as actuals. So Fleet gives us this little shortcut to see the actuals for this expect, but we've got one in iOS, and then we've got one in what we've defined as this JVM common source set, which if you recall from the slides, this is actually not a default source set, but we're able to create that with this API here in our configuration, where we just say common, we want to create this new JVM common source set, and we want to have it target Android and JVM. And so code that's Java code that are APIs that we'll see in both of those source sets, we can go ahead and add to this intermediate source set. And then on this side, in the platform code, we define that same function as an actual for the expect. And this is where we actually put the implementation. So it's very similar to the concept of an interface and a implementation for that interface. It just allows us to do that within that hierarchy of our source sets. And so here's just similar or very familiar for Java developers, date formatting code. Then we can jump to the iOS implementation, similar for those familiar with the NSDate, NSCalendar APIs. We're implementing this, how you would do it in Objective-C, but this is Kotlin code, accessing those iOS Foundation APIs in Kotlin native. So really cool how you can do this very seamlessly in Kotlin Multiplatform, whereas it's a bit more difficult, more boilerplate involved in a lot of other cross-platform technologies. Then let's real quick, just before we wrap up, take a look at some of the UI code. A good example of that would be, so we've got our presentation logic, our view models. This is where in the future I plan to have a Swift UI implementation that uses these same view models. And I've done some successful proof of concepts of that, but I just want to get it working in this app specifically. So in our UI, we've got this widget we've defined, which is replication status. And we're able to populate this widget from a reactive flow from our replicator. And I wanted to kind of show how easy this is to wire up, where we've got creating a replicator, we just get our sync gateway endpoint. We tell it we want to be a continuous replication, push and pull. We give it our collection we want to sync, and then we authenticate with our user. And then once we do that, we kind of saw earlier on where we can call start replication and stop replication from our platform code. In our iOS lifecycle, when we go active or inactive in the background, we can start and stop our replication. Similarly, we can do that in the Android app on our Android lifecycle. So yeah, we can get a flow though of our replication status. So we can observe changes to our replicator, and in the UI, we can then represent that in the status bar. And so we'll see real quick just what that looks like. When I type a note on one side, you can see the other side as well as this side doing a sync of that note. Real quick, just pops up briefly. But that's reacting to the status of our replicator and the progress, doing it in a quick progress bar. So, well, cool. That was kind of most of what I wanted to cover with the demo, and we can wrap up here and just and have a Q&A if there are any other questions or things you want to see.
We do have one question from Mark. Could the sample app, so cool by the way, work with Capella App Services, which is our hosted version of the Sync Gateway, cloud.couchbase.com, free trial, 30 days free trial, no credit card required for anyone that's interested. So
yeah.
could it work with App Services? Probably.
Yeah, definitely. I have not used App Services myself, but my understanding and what I've seen of it, it's very much going to be configurable in the same way. So we've got this data object sync gateway where we define our endpoint, and we're actually just doing that in our dependency injection domain module here, where we're giving it our URL, port, database name, whether or not to use the TLS connection. But yeah, very, very well could connect to a Couchbase Capella and App Services backend.
All right. Has anybody else any other questions? We don't have much question right now, so I'm gonna, maybe wait a couple of minutes if someone wants to ask the last question.
Yeah.
I have one, but that's more of a personal, interesting. Is your code on GitHub? Was that the question? Git? Is your code on Git? Yes. Is this available on GitHub?
Yeah. In fact, that was my last
Yes.
slide, which is currently it's in this pull request. I haven't merged it yet, but you can take a look at this pull request, number 23, and all the code that we took a look at is there, as well as the Kotbase library itself. You can take a look at that code.
That's very cool. Do you, let's say I want to contribute to that project because it's fantastic. Like, do you have guidelines to start contributing to your project? Are you looking for external contributors or help, or like, what can we do to help you, basically?
Yeah, I haven't really made any specific guidelines, but this is the repository. There's also a documentation website where I've borrowed a lot of the documentations from the Java SDK or that Couchbase has developed and kind of reworked some of the examples so you can see how it would look specifically with the Kotbase library. But as far as contributions, I'm open to ideas if there's anything that you feel like could be valuable. We mentioned there's the KTS extensions that we saw a few of. Some of those I got the ideas and some of the code from the Mola 17 library, which is excellent, and ported that over to work with the Kotbase library in Kotlin Multiplatform. There's also an extension for Kermit, which is a great logging utility for Kotlin Multiplatform. And so you can forward your Couchbase Lite logs to the Kermit logger, which is able to then direct those logs in various locations depending on a debug or a production build, that sort of thing. I also have paging extensions, which is a great Android library that has been ported to Kotlin Multiplatform by Cache App. And these paging extensions take advantage of those APIs to then pass in a Couchbase Lite query to do paging within your UI, which is really valuable depending on your use case. But yeah, as far as the roadmap goes for the library, I've implemented a lot of the stuff that I had on the roadmap fairly recently, including the 3.1 API update, which I just got out beginning of this month.
That's great.
But yeah, I'm gonna add this new sample to the sample apps. And another thing I've been considering is the ability to support async APIs natively. And so that's still kind of conceptual, but you saw a lot of the code where we're explicitly creating or getting on a coroutine context to access the database. And so the idea would be these APIs could kind of wrap that up under the hood. But yeah, something that's kind of specific to Kotlin, but really valuable when doing any sort of async work.
Do you think they have a multi-platform implementation of coroutines? Because that's sort of tied into the runtime, I guess.
Yeah. So the coroutines library is fully functional for Kotlin Multiplatform. A lot of JetBrains libraries actually have been adopting even the newer targets. That's one of the more recent updates, is they're now supporting the WASM multi-platform targets. And that's actually something that I would like to see developments on, and maybe there's been some explorations at Couchbase with getting Couchbase Lite to compile to WASM. And if that were something that were to come in the future, that could be something that would be really valuable for integrating with Kotlin Multiplatform and be able to use that common code to run potentially in the browser with
Yeah, that would be amazing. That was actually the question I wanted to ask you before seeing other question pop up. I know some people have tried it. I know there's a bunch of open source repos on Git, notably one of our ambassadors, Gabriel. He works at Lumen, I think. He did the Flutter SDK, and he has a version of Kotbase that compiled to WASM in the branch somewhere that needs some love. I need to go back into it, but yeah, that'd be fantastic.
That's awesome. Yeah, I'd love to explore that more. I think there's a lot of really valuable use cases for WASM, and Kotlin is really focusing on being a core language for that platform.
I have another question from Mark. Mark, can you maybe specify a little more your question? It's asking, are you using Couchbase this way for specific use cases you can talk about? Which way, Mark? And can you tell us about business case? Like, what are your Couchbase Lite business case? Because you said you were entrepreneur minded and you already had a couple business going on. So can you give us a couple examples?
So I've got an app in production that is using this library. It's a smaller app. It's for a festival actually, but they synchronize data with the app, and it works really well. It's a fairly simple use case, but I've done a lot of explorations for other potential use cases. One of the businesses I'm working on right now is actually already got a lot of Flutter application code in place, and so potentially in the future there might be opportunity to use Kotlin on that application as well. But yeah, they're each very interesting cross-platform technologies. Flutter kind of takes it from a UI first perspective, and Kotlin Multiplatform I feel like does the opposite, where it's kind of from the bottom up, and it leads to a lot of other opportunities that would be difficult to solve in existing apps, but allows for that sort of gradual adoption where you can kind of take a piece of your code and explore it. Is this something that doesn't require a lot of platform APIs, and we could really easily move this to common code.
Awesome. I think we're at time. So do you have one last message you want to send to the world, to our listeners?
It was a great opportunity today to share this project with you. It's been exciting to work on over the years, and yeah, I'd love to have people using it. Give feedback if you have any issues. I've had people ask questions in the issues here. I'm also available in the Couchbase communication channels, Discord, as well as the Kotlin Slack. There's a Kotlin Slack that is great to get help with there. And so, yeah, I'd love to interact with anyone that's using the library and has any feedback. So,
all right, awesome. Thank you so much for your time and your presentation. As you have a lot of comments about the quality of your talks and people thanking you in the Q&A, so you can take a look at those messages. So thank you so much, Jeff.